Hello, in this video we will be discussing about cinnamic acid. Cinnamic acid. That is, here we will be discussing the preparation, properties and main uses of cinnamic acid. The more cinnamic acid is C6H5 CH double bond CH. This is the molecular structure of cinnamic acid. This cinnamic acid is an unsaturated acid, and this IUPAC name of this cinnamic acid is 3-phenyl prop-2-enoic acid or 3-phenyl propionic acid. That is the IUPAC name of this cinnamic acid. Now let us consider the different methods which are used for the preparation of cinnamic acids. First one, this Perkins reactions. Perkins reaction is here Perkins condensation. Here, by heating this benzaldehyde with acetic anhydride at 180 degrees Celsius in presence of sodium acetate yields this cinnamic acid. Is the first method means by Perkins condensation. In this Perkins condensation, benzaldehyde is heated with acetic anhydride at about 180 degrees Celsius in presence of sodium acetate. We will get cinnamic acid. Then second method by Claisen reaction. In this reaction, by treatment with benzaldehyde with ethyl acetate, benzaldehyde with ethyl acetate in presence of sodium ethoxide. Here in presence of sodium ethoxide, followed by acid hydrolysis of the resulting ester. So here first this by Claisen reaction, this benzaldehyde is reacted with or treated with ethyl acetate in presence of sodium ethoxide. That means C2 sorry here C2H5 ONA, it is sodium ethoxide. Okay, and this benzaldehyde is reacted with ethyl acetate in presence of sodium ethoxide, followed by the acid hydrolysis of the resulting ester. So when this benzaldehyde is reacted with ethyl acetate in presence of sodium ethoxide, we will get ethyl cinnamate. Then this ethyl cinnamate is ethyl cinnamate undergo acid hydrolysis. We will get cinnamic acid. The next one, this Novenangel reaction. In this reaction, this benzaldehyde is reacted with malonic ester. That is diethyl malonate in the presence of a base. Generally is piperidine. In presence of a base, it is piperidine, and followed by acidification, we will get cinnamic acid. Fourth one, the oxidation of benzalacetone with hypochlorite. Oxidation of benzalacetone with hypochlorite. In this reaction, this benzalacetone, this is benzalacetone, that is C6H5CH double bond CHCOCl, that is benzalacetone is reacted with sodium hypochlorite, or it may be a sodium hypobromate. Here hypochlorite, sodium hypochlorite. Benzalacetone is reacted with sodium hypochlorite. We will get cinnamic acid. This benzalacetone can be prepared by the reaction with benzaldehyde with can be prepared by the reaction of benzaldehyde with this acetone. By acetone in presence of a base. We get benzalacetone. This benzalacetone can be reacted with this sodium hypochlorite to get cinnamic acid. So this is the different methods of preparation of cinnamic acid. First one by Perkins condensation. Here benzaldehyde is reacted with acetic anhydride in presence of sodium acetate. We will get cinnamic acid. Then second one by Claisen reaction. In this reaction, benzaldehyde is reacted with ethyl acetate in presence of sodium ethoxide, followed by the acidification of resulting ester. We will get cinnamic acid. Then third one by Knoven-Angle reaction. In this reaction, this benzaldehyde is reacted with malonic ester in presence of a base. Generally we use piperidine. Followed by acidification, we will get cinnamic acid. Then fourth one by the oxidation of benzalacetone with hypochlorite. This benzalacetone means C6H5CH double bond CHCOCH3. This can be prepared by the reaction of benzaldehyde with acetone in presence of a base. This benzalacetone can be oxidized with this sodium hypochlorite. We will get cinnamic acid and chloroform. Then next, the properties of cinnamic acid. The chemical properties of cinnamic acid may be divided into three sections, that are reactions due to the double bond. Similarly, reactions due to the carboxylic group. Similarly, reactions due to aromatic ring. So the chemical properties of cinnamic acid may be for convenience, it may be broadly classified as three part: reactions due to double bond, reactions due to carboxyl group, and reaction due to aromatic ring. The first one, reactions due to double bond. First one, addition of H2. In this reaction, cinnamic acid undergo reaction with undergo hydrogenation. In presence of nickel as catalyst, we will get this one, beta phenyl propionic acid. It may have also called 3-phenyl propanoic acid. Then second reaction, addition of halogens. In this reaction, the halogens can add at the double bond of cinnamic acid, yield dihalocinnamic acid. Here let us consider an example. The cinnamic acid is reacted with bromine. We will get dibromocinnamic acid. Or this one, 2,3-dibromo 3-phenyl propanoic acid. This reaction is generally carried out in carbon tetrachloride. That is, the cinnamic acid reacts with the bromine in carbon tetrachloride or CCl4. We will get this one, dibromocinnamic acid, or 2,3-dibromo 3-phenyl propanoic acid. Then next one, reduction by lithium aluminum hydride. In this reaction, this cinnamic acid reduced in presence of this lithium aluminum hydrate. We will get alcohols. But the resulting product depends upon the reaction condition. Depends upon the reaction condition. Careful reduction by this lithium aluminum hydrate at very low temperature, around minus 10 degrees Celsius. This cinnamic acid reduces the carboxylic group to primary alcohol. Reduces the carboxyl group into primary alcohol, keeping the double bond, intact to yield cinnamyl alcohol. But here this one cinnamic acid reacted with this lithium aluminum hydrate. At normal condition, we will get 3-phenyl propanol. Next one, cinnamic acid undergo reduction with sodium amalgam. This cinnamic acid undergoes reduction with sodium amalgam and water to give 3-phenyl propanoic acid. Or we say that this cinnamic acid undergo reduction in presence of sodium amalgam and water. We will get this one 3-phenyl propanoic acid. Then next one, ozonolysis. Here in this reaction, cinnamic acid or ozonolysis of this cinnamic acid yields benzaldehyde and glyoxalic acid. The next one, hydroxylation. Hydroxylation of cinnamic acid with OSO4, that is osmium tetroxide, yields 2,3-dihydroxy 3-phenyl propanoic acid. This formed this dihydroxy compound, that is this 2,3-dihydroxy 3-phenyl propanoic acid, on cleavage by this one per iodic acid, that is HiO4 will give this one benzaldehyde and glyoxalic acid. Similarly, the next reaction, dimerization. When the cinnamic acid exposed to sunlight, it dimerizes truxinic acid and truxilic acid. Here this C6H5 truxilic acid, this C6H5 are on opposite side, but in truxinic acid, this C6H5 also are on same side. The next one, reactions due to carboxyl group. First one, decarboxylation. The reaction, when heated with soda lime, we will get this one, styrene. That is, cinnamic acid undergo decarboxylation in presence of soda lime, we get styrene. The next one, reaction with sodium bicarbonate. That is, when cinnamic acid reacted with sodium bicarbonate solution, this cinnamic acid yields sodium cinnamate with the effervescence of carbon dioxide, gas. Then third one, esterification. Cinnamic acid reacts with alcohols in presence of acids. We will get ethyl cinnamate. Then next one, formation of acid derivatives. When cinnamic acid is reacted with ammonia, it is cinnamomide. We will get cinnamomide. Then this cinnamic acid is also reacted with this PCl5. We will get cinnamyl chloride. Next one is reactions due to aromatic ring. This substituent on this benzyl ring, that is the C6 CH double bond CH COH, is an deactivating this benzyl ring. So this cinnamic acid is slower towards electrophilic substitution than benzene. Here consider one reaction, that is cinnamic acid undergo nitration in presence of HNO3 and H2SO4. We will get orthonitrocinnamic acid and paranitrocinnamic acid. This paranitrocinnamic acid is major production. Next, this uses of cinnamic acid. The cinnamic acid, the main uses are the following. That is, cinnamic acid is used in manufacturing its methyl, ethyl and benzyl esters for the perfume industry. It is used in the preparation of certain pharmaceuticals. Similarly, it is used in the manufacture of flavors and dyes, and it is used as a precursor to the sweetener aspartame. So these are the different uses of cinnamic acid. For the uses of cinnamic acid. So here in this video we already discussed the preparation and methods of preparation. Similarly, important chemical properties and uses.